Hi, this is my Lab 1 presentation for Physics 2211. I'm just going to jump right into it. So the objective of this lab was to observe how the momentum principle / Newton's second law applies in real life by modeling the principle of position versus velocity and time of an object in motion. So we wanted to observe how a computational model and observational physics can differ in practice. And we did this by recording a video of an object in motion with a constant velocity, ideally with no forces acting upon it. And the object I chose to model for this project was a circular bottle of lotion. One thing I made sure to do was to make sure that the bottle was full to ensure that there was no change in velocity due to the contents of the bottle. So we used one of the principles in this project was Newton's first law. An object will not change its motion unless it's acted on by an unbalanced force. And one of the other principles that we used was Newton's second law / the momentum principle, which is that the change in momentum of a system is equal to the net force acting on the system multiplied by the duration. So the way we learned this in the textbook was the change in momentum is equal to the net force multiplied by the change in time. And the way we learned this in class and the way that it was applied throughout the course of this lab was the final velocity equals the initial velocity plus the net force divided by the mass multiplied by the change in time. And this equation is used later on throughout the presentation. So this is an example of the tracker software. The object that I had, this lotion bottle, moved from right to left. I chose to orient the axis in a way that the position would reflect ascending magnitude, so it would become more and more negative, and we'll talk a little bit more about why I made that decision in a second. So as you can see, the center of mass was selected, the diameter of the lotion bottle was selected, and you can also on the top right here see a graph of the time versus position, which was generated by Tracker, and then right here all the data points are listed, which were then used to create a prediction of the position. So in modeling this, there was a couple data points that I wanted to get, and those were taken from the Tracker software. So I know the observation start time was 0 seconds. The first two data points were in time. The units were time in seconds and then position in millimeters. So the first two data points were time equals 0 and then position equals negative 22.76. And then the second data point was time equals 0.033 and then the position equals negative 78.39, and as you can see, the position keeps getting more and more negative, which is why the axis was oriented the way that it was. So to calculate the velocity, I did the change in position over the change in time, which gave me negative 1,685.75 millimeters per second, and that translated to SI units at negative 1.685 meters per second. I also know the time of my last observation was 0.867 seconds, which is where all of the graphs end. And then assuming constant velocity, I was able to derive the equation x equals negative 1.685 multiplied by the time, and negative 1.685 was my constant. So this was just calculating the initial velocity and using that to model what the velocity would have looked like had it stayed constant throughout. And as you can see in this graph of the model versus the experiment, the position did not do what it was expected to do. So as you can see, both of these are downward sloping, both the experimental position and the model position. But the position in the model moves further and further because it is not accounting for the drag of the carpet that the experiment is. So the experimental position is what the actual data points were observed as. And in the analysis, there's just a couple things I wanted to highlight. Like I said, the model data and the experimental data look very different, and that's due to the friction from the carpet. The experimental data did not go as far as the model predicted it to. And the two forces acting on this object were the force of the push and the force of the friction. And then lastly, the orientation of the axis was chosen to show an increase in the magnitude over time. Like I said, flipping the axes would not change the conclusion from the data, but it would change the values that the data gave. Thank you.